I'm not going to spend too much time talking about that. I will tell you about why the research that I'm doing, I think it's a little bit different than what's been done in the past. There's three basic reasons for it. One, VMT has kind of been the metric that's been used as the dependent variable in most of these studies. And then the assumption has been if you reduce VMT, then you'll be able to reduce emissions. Unfortunately, there haven't been a lot of studies that actually try to estimate what the emissions actually are. So one of the big things that I'm able to do is I'm able to not only estimate VMT, but I'm also able to estimate fuel consumption, which is much more directly related to emissions than VMT is. Another big difference is data. Lots of previous transportation studies are based on surveys, which are great for getting individual data about individual households or individual drivers, but a lot of times the sample sizes are small and they also lack geographic coverage. My data comes from the Smog Check program from California. It's the entire state. I have all registered vehicles and all vehicles that are susceptible to smog check. So I have the entire state of more than 20 million vehicles in my data set. And last thing is methods. A lot of studies, previous studies are either descriptive or they're using standard regression analysis. I think space is important, and I'm going to talk to you about that in a little bit. And so I'm using more spatially robust methods that are going to control for possible errors. Okay, so here's the data that I just alluded to. The Smog Check program in California, for those of you who are not familiar, California has historically bad air quality, and so the government put in a program requiring all vehicles to go to these special smog check stations and get their emissions measured. I'm interested in the emissions, but the bigger part of that smog check information that I'm interested in is every time you go to smog check, there's an odometer reading that's taken on your car. And so that's going to be the basis for my VMT estimate, because if I can track cars throughout the years and an odometer reading shows up every time, I can estimate how far they've traveled. In addition to that, I've got DMV data, so I know where each vehicle lives. I've got fuel economy data from the EPA, so I'm going to be able to know what the fuel economy is for every vehicle in my sample. And then I'm pulling in terms of the policy variables and the independent variables I'm interested in, I've got census data that's going to have socioeconomic and some transportation variables in there too. Some USGS and other UC Davis information on land cover and land use, which is going to let me come up with some density type variables. And then some fuel price data from Opus. Okay, so how to go about doing this? Basically, I have a panel of all vehicles in the state. They show up from time to time in smog check data with an odometer reading. I look at two odometer readings, I subtract the difference, figure out, scale that time difference up to about a year, and that's going to be my estimate for VMT. The year that I'm interested in, and all of the results are going to be presented for, is 2005. New vehicles do not need to be smog checked until 6 years after they've been purchased. So 2005 is kind of the most recent year that I can get all of the vehicles in the state that are going to show up. So once I have that VMT estimate, I've got miles traveled during 1 year, put that together with the fuel economy estimate, and I can get at how many gallons of gasoline were consumed by that vehicle in that year. So now I've got VMT, I've got fuel consumption, and I've got the home zip code, so I can aggregate all of these vehicles by zip code and calculate mean fuel consumption or median fuel consumption or any kind of aggregate statistics that I want and map those across the state. So this is what VMT looks like in California. Darker areas are places that have higher average VMT. So again, these are all the zip codes in the state, and for each zip code I'm showing you the average VMT in that zip code. So darker areas have higher average VMTs, lighter areas have lower VMT. San Francisco is here, LA here, San Diego here. Those are the three major population centers. You see the basic trend, you've got low VMT in the kind of urban center areas, and then as you extend out to the suburbs or exurbs, you get higher VMT. So that's kind of your basic core city expansion growth story. Another story you can tell is an isolation story. People that live farther away from points of interest tend to drive more. I think that's something you can see in the Central Coast here, or as you get further away in the Sierras and up the North Coast. So this map, I love this map. I could talk about the entire presentation just from this This here? That is no where?
The high density, lots of miles.
That one?
Further down. That big thing.
This thing? I don't know. I thought Palm Springs was up here. That could be wrong. Anyway, I'm not going to talk about this map for the rest of my entire presentation. But you can not only look at statewide trends. Oh, 6 slides. Yeah. Well, you can also zoom in and look at individual regions. So I've got maps for the San Francisco Bay Area, and I've got maps for LA as well. Those are some of the sort of things. Okay, so the variables I'm interested in, as mentioned before, income, other socioeconomic variables that I'm pulling from the census. I can control for a lot of those things, which is a useful thing to be able to do if I'm interested in these other variables. The census also has information on mean travel time to work in different zip codes, prevalence of other modes of transportation, how old the vehicles are. All of these things are kind of related to the policy variables that I'm interested in. Now, density, when I mention density, you can measure density in lots of different ways. You can talk about population density, you can talk about housing density, you can talk about land use in terms of what is categorized as urban. So there's lots of different measures of that. All right, so very quickly, just about why I think space might matter, especially in transportation, where we're talking about vehicles that are moving. I mean, that's the essence of transportation, is that these vehicles are not just sitting still, they're driving and they're moving everywhere. So you might think that the density in your zip code is not only important, but the density in your neighboring zip codes also may be important. Maybe access to public transportation isn't just important where you are, but it's important where you're going. So when you go, if you're using regular linear regression, which a lot of people do, and there's problems with that if you have things that are not in your model that are correlated across space. So basically, all I want to get into here is that I'm using methods that are going to control for that spatial autocorrelation that might exist. Okay, so let's get to some results here. So from the analysis, first column here is a regression analysis using all of California, and then I look specifically at the Bay Area and the South Coast. Signs here, I'm showing positive or negative signs for the signs of the coefficients. If they're significant, a 0 means that they're not significant. So going through a lot of these estimates are intuitive. You've got higher density areas drive less. A lot of things are closer to them. The further that you live from your work indicates that you drive more, where individual zip codes drive more. Higher fuel economy consumes less fuel. But they also differ across space, right? If you look at LA, we've got public transportation and alternate modes of transportation don't really have any significant impact with fuel consumption. Whereas in the Bay Area, biking and public transportation are significantly negatively correlated with fuel consumption. If you bike, places where people bike more consume less fuel. Okay, so what can we say? We've got things that I just talked about. Places, the trend seems to be areas that are more dense, drive less and consume less fuel. That's a result that's shown up in the literature repeatedly, and I see evidence of that here also. Also, zip codes with better connectivity, shorter commute times, and more prevalent use of alternative modes also tend to drive less and consume less fuel. Now, there are definitely some issues here, and this is where some of my future work is going to go. You may have noticed that I've got a negative sign on my income variable and a positive sign on my gas price variable. So that, taken at face value, those would say more wealthy individuals or more wealthy households drive less, and when the gas price is more expensive, you also drive more, which is not intuitive, at least from an economic standpoint. So there are some possible explanations for that. One is that all of my VMT estimates are at the individual vehicle level, whereas all of my census variables are at the household level. And so to that extent, I'm missing the story about how households distribute their miles within vehicles in the same household. So it may be that richer people own more cars, and they just happen to drive each of their cars less than a household that only owns one vehicle. And I can't, as of yet, I can't say anything about that until I match up the vehicles into households. Other things that I want to do, I want to make the final leap from fuel consumption to emissions. So I want to look at carbon emissions that are going to be some scalar multiple of fuel consumption. I want to use the actual emission estimates that also come from the smog check that are responsible for smog formation and particulates. Get them into the analysis and see what those look like across the state. I want to estimate VMT not just for 1 year, but I want to look at it for, I can do it for any year prior to 2005. So I'm going to go back to 2004, 3, 2, and build up sort of a time series of how these patterns are changing over time and what that looks like. And I want to look at not just a single number like a median or an average, but I want to look at the distribution of VMT. What does that look like? Is it normal? Is it skewed with a very long tail out right? What does it look like, and are there any additional information that we can get from that? References if you're interested, and that is it for right now. So thanks a lot.
And in general, unless there's